Magandang araw! Sama-sama tayong matuto sa Teacher Sal Learning Resource Channel. Revised K-12 Curriculum Math 5 Quarter 2, Week 7. Applying divisibility rules to determine if a number is divisible by 4 and 8 by observing the number's last 2 or 3 digits. Applying divisibility rules to determine if a number is divisible by 6 and 12 by applying two divisibility rules. Applying divisibility rules to determine if a number is divisible by 11 by observing the sum of the alternating digits of a number. Put check in the appropriate space if the number is divisible by the number in the top row. Put X if it is not. Our lesson purpose. From our previous discussions, we already learned some divisibility rules that can help us determine if a number is divisible by another number. Now, let us take the numbers from our review. We already identified in our review some of the factors of these numbers by applying the divisibility rules that we know. However, these are not the only factors of our given numbers. For us to determine some other factors of these numbers, we will be learning some more divisibility rules in our next lessons. These divisibility rules will help us identify some factors of large whole numbers. Before we proceed with our new lesson, let us first review some of the terms that we use in learning divisibility rules. Let us first redefine the following terminologies. Factor, common factor, multiple, divisible. Subtopic 1. Apply divisibility rules to determine if a number is divisible by 4 and 8 by observing the number's last 2 or 3 digits. For Group 1 and 2. On Christmas, Tio Manuel wanted to give some pamasko to his 4 inaanak. He prepared 5 packets containing money bills and coins. However, he wanted to make sure that each of them would receive an equal amount. Let us help Tio Manuel determine which packets he can possibly give by completing the table. For packet A, packet B, packet C, packet D. Packet E. Here are the tables to be completed. Group 3 and 4. The same packet will be given. However, the number of inaanak will be 8. You will complete the table. From the activity, we can generate the following summary. By observing the last digits of the numbers that can be divided 4 and 8, we can generate the following divisibility rules. Divisibility rule by 4. A number is divisible by 4 if the number ends with 2 zeros. The number formed by its last 2 digits is a multiple of 4. In the activity, we can notice that 4,500 and 5,000 both end with two zeros. Therefore, we can say that 4,500 and 5,000 are divisible by 4. Now, let us observe 1,532. The number formed by its last two digits is 32. Since 32 is a multiple of 4, then we can say that 1,532 is divisible by 4. Since 4,500, 5,000, and 1,532 can all be divided by 4, then 4 is a common factor of these three numbers. On the other hand, let us take 1,550. The number formed by its last two digits is 50. Since 50 is not a multiple of 4, then we can say that 1,550 is not divisible by 4. Determine if the following numbers are divisible by 4. Here are the key answers. Divisibility rules for 8. A number is divisible by 8 if the number ends with 3 zeros. The number formed by its last 3 digits is a multiple of 8. In the activity, we can notice that 5,000 ends with 3 zeros. Therefore, we can say that 5,000 is divisible by 8. Now, let us observe 1,408. The number formed by its last 3 digits is 408. By mere inspection, we can say that 408 is a multiple of 8. Since 408 is a multiple of 8, we can say that 1,408 is divisible by 8. Since 5,000 and 1,408 can both be divided by 8, then 8 is a common factor of these two numbers. On the other hand, let us take 1,532. The number formed by its last 3 digits is 532. Since 532 is not a multiple of 8, then we can say that 1,532 is not divisible by 8. As we observe, 1,532 is divisible by 4, but not divisible by 8. This tells us that not all numbers that can be divided by 4 can be divided by 8. Determine if the following numbers are divisible by 8. Here are the key answers. Determine whether the following numbers are divisible by 4 or 8 using their divisibility rules. More than one rule may apply. Here are the correct answers. Put a number on the line to make the given number divisible by numbers inside the parentheses. Identify the common factors of the given numbers using the divisibility rules for 4 and 8, and circle all the number that applies on each row that corresponds to each item. Here are the key answers. Subtopic 2. Apply divisibility rules to determine if a number is divisible by 6 and 12 by applying two divisibility rules. Tia Linda is preparing money to put in ang pao, which she will give to her pamangkin during Christmas. Her four children gave her money to put inside the ang pao. It consists of money bills and coins which are stored inside their respective buckets. Tia Linda wanted to know which of the four packets given to her contained an amount that could be divided equally among 6 ang pao. Let us help Tia Linda with the task. Packet A, Packet B, Packet C, Packet D. Complete the table. For group 3 and 4, the same packet will be given. However, the number of ang pao will be 12. Complete the table. From the activity, we can generate the following summary. Now, let us observe all the numbers that are divisible by 6. Using our previous knowledge on divisibility rules, what do you think is common among all these numbers? How about for those numbers that are divisible by 12? By observing the common divisibility rules that applies to the numbers that can be divided by 6 and 12, we can arrive to this another set of rules. Divisibility rule for 6. A number is divisible by 6 if it is both divisible by 2 and 3. From this rule, for us to determine whether a number is divisible by 6, first determine if the number is divisible by 2 by applying the divisibility rule for 2. Second, determine if the number is divisible by 3 by applying the divisibility rule for 3. Let us take 4,500 as an example. The last digit of 4,500 is 0, which is considered an even number. Therefore, we can say that 4,500 is divisible by 2. The sum of the digits of 4,500 is 9, which is a multiple of 3. From this, we can say that 4,500 is also divisible by 3. Now, since 4,500 is both divisible by 2 and 3, then it is divisible by 6. On the other hand, let us take a look at 3,225. The last digit of 3,225 is 5, which is not an even number. Since it is odd, we can say that this is not divisible by 2. From this, we can already conclude that 3,225 is not divisible by 6, since it fails the condition that it must be divisible by 2. Since 4,500, 1,272, and 5,202 can all be divided by 6, then 6 is a common factor of these three numbers. Determine if the following numbers are divisible by 6. 558, 558. First, let us determine if the given number is divisible by 2. Since the last digit of 558 is 8, which is an even number, then we can say that 458 is divisible by 2. Second, let us determine if the given number is divisible by 3. The sum of the digits of 558 is 18, and 18 is a multiple of 3. Therefore, 558 is also divisible by 3. Now, Since 558 is both divisible by 2 and 3, then we can conclude that 558 is also divisible by 6. 1107. First, let us determine if the given number is divisible by 2. Since the last digit of 1107 is 7, which is not an even number, then we can say that 1107 is not divisible by 2. Since the number is not divisible by 2, then we can also conclude that 1107 is not divisible by 6. 7142. First, let us determine if the given number is divisible by 2. Since the last digit of 7142 is 2, which is an even number, then we can say that 7142 is divisible by 2. Second, let us determine if the given number is divisible by 3. The sum of the digits of 7142 is 14, and 14 is not a multiple of 3. Therefore, 7142 is not divisible by 6. Now, since 7142 is only divisible by 2 but not by 3, then we can conclude that 7142 is not divisible by 6. Divisibility rule for 12. A number is divisible by 12 if it is both divisible by 3 and 4. From this rule, for us to determine whether a number is divisible by 12, first, determine if the number is divisible by 3 by applying the divisibility rule for 3. Second, determine if the number is divisible by 4 by applying the divisibility rule for 4. Let us take 1272 as an example. The sum of the digits of 1272 is 12, which is a multiple of 3. Therefore, we can say that 1272 is divisible by 3. Furthermore, the number formed by the last two digits of 1272 is 72, which is a multiple of 4. This means that 1272 is also divisible by 4. Now, since 1272 is both divisible by 3 and 4, then it is divisible by 12. On the other hand, let us take a look at 3202. The sum of the digits of 5202 is 9, which is a multiple of 3. Therefore, we can say that 5202 is divisible by 3. However, the number formed by the last two digits of 5202 is 2, which is not divisible by 4. This means that 5202 is not divisible by 4. Since 5202 is only divisible by 3 but not by 4, then we can say that it is not divisible by 12. Since 4500 and 1272 can all be divided by 12, then 12 is a common factor of both of these numbers. Determine if the following numbers are divisible by 12. 636. First, let us determine if the given number is divisible by 3. The sum of the digits of 636 is 15. Since 15 is divisible by 3, then we can say that 636 is also divisible by 3. Second, let us determine if the given number is divisible by 4. The number formed by the last two digits of 636 is 36. Since 36 is a multiple of 4, then we can say that 636 is divisible by 4. Now, Since 636 is both divisible by 3 and 4, then we can conclude that 636 is also divisible by 12. (2,563) 7,500. Determine whether the following numbers are divisible by 6 or 12 using their divisibility rules. Write n if the number is neither divisible by 6 and 12. More than one rule may apply. Here are the key answers. Determine whether each statement is true or false using the divisibility rules for 6 and 12. Write your answer on the line before each item. Identify the common factors of the given numbers using the divisibility rules for 6 and 12, and circle all the number that applies on each row that corresponds to each item. Here are the key answers. Identify the common factors of the given numbers using the divisibility rules for 6 and 12. For day 3, apply divisibility rules to determine if a number is divisible by 11 by observing the sum of the alternating digits of a number. At a Christmas family reunion, 11 children sang Christmas carols for their older relatives to ask for pamasko. 4 relatives gave an envelope containing an amount that they must equally divide among themselves. Now, they have to identify if the amount contained in each envelope can be equally divided among themselves. Let us help them determine which amount can be divided equally among 11 of them and which is or are not. Here are the envelopes. From the activity, we identified that 1,650, 4,400, and 3,905 are divisible by 11, while 3,550 is not. Let us investigate these numbers by filling out this table. Now, let us focus on the numbers that are divisible by 11. What can you observe in the difference between the sum of the odd position digits and the even position digits? From our observation of the difference between the odd position digits and even position digits of the numbers that are divisible by 11, we can generate this rule. Divisibility rule for 11. A number is divisible by 11 if the difference between the sum of its odd position digits and even position digits is A, 0, or B, a multiple of 11. From this rule, for us to determine whether a number is divisible by 11, first identify and label which digits of the number are odd position and even positioned. Second, take the sum of the odd positioned digits and even positioned digits. Third, take the difference between the greater sum and the lesser sum. Lastly, observe if the difference is 0 or a multiple of 11. Let us take 1650 as an example and apply this rule. Labeling the odd position digits and even position digits in 1650, we will have. After labeling, we can see that the digits that are odd positioned are 1 and 5, while those that are even positioned are 6 and 0. Next, taking their sums, we have odd position 1 plus 5 equals 6, even position 6 plus 0 equals 6. Then subtracting these sums, we will have difference of sums 6 minus 6 equals 0. Now, since the difference between the sums of the odd position digits and even position digits of 1650 is 0, then we can say that it is divisible by 11. On the other hand, let us take a look at 3550. Labeling the odd positioned digits and even position digits in 3550, we will have. After labeling, we can see that the digits that are odd positioned are 3 and 5, while those that are even positioned are 5 and 0. Next, taking their sums, we have odd position 3 plus 5 equals 8, even position 5 plus 0 equals 5. Then subtracting these sums, we will have difference of sums 8 minus 5 equals 3. Now, since 3 is neither 0 nor a multiple of 11, then we can say that it is not divisible by 11. From our activity, since 1650, 4400, and 3905 can all be divided by 6, then 11 is a common factor of these three numbers. Let us verify if this divisibility rule applies to our given values. For 1400. Difference of sums is 4 minus 4 equals 0. For 1400 is divisible by 11. 3905. Difference of sums 14 minus 3 equals 11. $3,904 is divisible by 11. 2,650. Difference of sums 7 minus 6 equals 1. $2,650 is not divisible by 11. Write D if the given number is divisible by 11. Write n if the number is not. Here are the correct answers. Encircle which of the following numbers in the table is divisible by 11. Put a number on the line to make the given number divisible by the numbers inside the parentheses. Here are the correct answers for letter A and B. For day 4. From the discussion for this week, when can we say that a number is divisible by 4, 8, 6, 12, and 11? This week's lesson not only taught us about how to apply divisibility rules, but we were also able to learn how to deal with money. Do you think it is important to manage and spend one's money correctly? What ways can you think to make wise use of your money? Aside from being aware of our use of money, we also get to revisit one of the prominent cultures of Filipinos, which is the celebration of Christmas. What do you think is the importance of this celebration among us? How can you make your own celebration of Christmas more meaningful? Complete the chart. Draw a happy face in the appropriate space if the given number is divisible by the number in the top row. Draw a sad face if not. Identify the common factors of the given numbers using the divisibility rules 4, 6, 8, 11, and 12. If the numbers in the top row is a common factor of the given numbers, shade the appropriate box with a red color. Shade the box blue if otherwise.